Good morning to all. Today we are going to discuss about the particle size determination using diode laser. Aim: to determine the particle size using the diode laser, apparatus required: the laser source, and then the glass plate having a lycopodium powder, and the stand and the screen. The formula for to find the radius of the microparticle is A is equal to 0.61 lambda d divided by R. So lambda, which is the wavelength of the laser used, here the semiconductor diode laser is used, the wavelength should be lambda is equal to 6000 Armstrong, and d is the distance between the glass plate and the screen, R is the radius of the first order ring. So this is the tabulation which contains d and then diameter of the first order ring, radius of the first order ring, and to find the radius of the microparticle. So how it will work? It will work on the from the laser source, the laser light which comes out, and it is fall on the glass plate which contains the lycopodium powder. So due to the principle of diffraction and the interference, so the diffraction which spreads the light, and the light will be interfere through the airy diffraction, and it forms the constructive and destructive interference. So due to that it forms a circular rings. If the circular ring are very closer, then the particle size is very large. If the circular rings are very there is a gap in that circular rings, first ring and the second ring, so the particle size is very small. So from that radius of the circular ring, so we have calculated and we have written in the table. We have find out a diameter of the first order ring, and from the diameter we calculated a radius. So from that radius we calculated a microparticle size, so which is of the 10 to the power minus 6 meter, so which is micrometer. Thank you.